Solve the system of nonlinear equations using the substitution method. In order to use substitution, we pick one of the equations and solve for one of the variables and then plug that into the other equation. Since this first equation is already solved for y, we'll use that x squared plus 1 quantity and plug it in for y in the other equation. So the second equation is y minus 4x is equal to 1, and we plug x squared plus 1 into the y variable of that second equation. This enables us to merge the two criteria into a single equation that now only has one variable, so we can solve for x. Notice the equation we now have is quadratic, and anytime we find ourselves with a quadratic equation, we start by setting it equal to 0. So first let's rearrange our terms. We have x squared minus 4x plus 1 is equal to 1 on the right, and when we subtract 1 from both sides to set it equal to 0, we end up with x squared minus 4x is equal to 0. Now our quadratic has only two terms, and we can factor it because there's a common x to both terms, so we can factor that x out and end up with x times x minus 4 that remains. Now we can set each of these factors equal to 0, so we get x is equal to 0, and x minus 4 is equal to 0, and after we add 4 to both sides, we'll get x is equal to positive 4. Remember, the solution to a system of equations is going to be an ordered pair, so we have two x values, which means that we have two potential ordered pair solutions to the system. These ordered pairs would also be the intersection points between the two graphs. So to determine the corresponding y values, let's start by taking the x-coordinate 0 and plug it back into the first equation. When we do that, we see that y is equal to 0 squared plus 1 and y is equal to 1. So 1 is the corresponding y value that completes the ordered pair in the first equation, but we do need to verify that this is also an ordered pair solution to the second equation. It needs to satisfy both of them in order to be a solution to the system. So we can plug 1 in for y and 0 in for x, and we see that that does actually satisfy the second equation, and therefore 0, 1 is an ordered pair solution to the system. Now let's plug 4 back into the first equation to determine the corresponding y value output. So we have y is equal to x squared plus 1. We plug 4 in for x, and we see that y is equal to 17. So 17 is the corresponding y value that completes the ordered pair from the first equation. But let's make sure that we get the same ordered pair solution from the second equation. This time let's just plug the ordered pair point in. So we have y is equal to 17 minus 4 times x is equal to 4, and that should be equal to 1. And it is, because 17 minus 16 is equal to 1. So this ordered pair is an ordered pair solution to both equations, and we do actually have two solutions to the system.